Hey, what is up guys? Welcome to another LeetCode video. Today we're going to be looking at problem number 1337. It's going to be the k weakest rows in a matrix. Going to be a very interesting problem today. Let's take a look at it. Okay, so let's start off by reading off the problem. It says, you're given an m times n binary matrix called mat of ones and zeros. Ones representing soldiers, 0 representing civilians. The soldiers are positioned in front of the civilians, that is, all the ones will appear to the left of all the zeros in each row. A row I is weaker than a row J if one of the following is true. The number of soldiers in row I is less than the number of soldiers in row J, or both rows have the same number of soldiers, I less than J. So basically, what I'm getting is that if we have less ones in one row than the other, that makes it weaker, or the indice of that row is going to determine which one comes in first. Then it says return the indices of the k weakest rows in the matrix order from weakest to strongest. And then we're giving an example of a matrix k, and basically the k just represents, okay, how many of those weak rows do you want me to give you back? So let's get right to it. Okay, so starting off, I'm just going to declare a variable that I'm going to use to basically call back the number of the indice, where I'm going to store the indice value on my matrix. This will make sense as we go along the problem. And I'm just going to do mat0, basically taking in the length of the first row. I know all the rows are going to be the same, so it's okay if we just put in 0. Next up, we're going to open a for loop where we're going to append to the end of each row the number of that indice. So for that, we're just going to do for, and I'm just going to initialize an integer here equals 0, I, and for as long as I is less than mat dot size, so it's going to take the length of how many rows there are in my matrix. And so basically inside this for loop, all we got to do is append the indice to the end of each row. So for that, we're going to do mat, or matrix, then that rows. So we're choosing that row to append that indice number 2 dot push back, and then we're just going to do I, because I is the number of our indice. Okay, so next up, now we want to sort our matrices, and for this we're going to use a little bit of lexicography. You'll see what I mean. So for this, we're going to do sort, and then mat dot begin. Don't forget your parentheses. Mat dot end. And what this is basically going to do, I'm going to draw it out real quick. So if we are given the matrice, let's just say 1 0 0 0 1 1 1 0 1 0 0 0 and 1 1 0 0. And since we already appended that number of the row to the end of the matrix, this would be 0, 1, 2, and 3. Okay, so now the way the sort function is working, okay, so basically it's organizing the matrix using lexicography. What that means is that it's comparing the first digit of each row and comparing it to the first digit of each one of the other rows. So in this matrix right here, it's comparing the first one to the first one to the first one. And in this case, since they're all the same, they all have the same value. Now, as we move on to the second digit, it's going to compare the 0, the 1, 0, 1. And so as we see, the 1 is greater than the 0 in both of these cases. So it's going to now organize it as such so that these ones are pushed to the back of the matrix. So now we would have 1 0 0 0 0, then 1 0 0 0 2, then the rest would be 1 1 1 0 1, and 1 1 0 0 3. Now it would analyze the third element of each row. So it would look at these numbers right here. And since, they're all pretty much the same except for our row 1, it would just push the 1 to the end, to the back, and so on and so forth. So by adding the indice to the end of our matrix at the beginning, we're able to use the indice as a tiebreaker between each row if they happen to have the same number of ones or zeros. Okay, so now that we know that our matrices are organized, now all we got to do is just percent the rows, the weakest rows, such that they match k. So if k equals 2, we're just going to return the first 2 weakest rows, basically. So for that, I'm going to initialize a vector int, let's call this my vector. And now all we got to do is make a for loop where we're going to retrieve the indice off of each row in the weakest order. To do this, we're going to start a for loop. So for, and I'll just call this integer r. And as long as r is less than k and r plus plus. So now all we got to do is retrieve that last number off of each row, which as we know is our indice. To be able to do this, we're going to use that variable we declared in the beginning called int q equals mat0.size. So to do this, all we're going to do is my vector dot push back, which is going to append that number onto our vector. And we're going to do mat at position r, which is going to be that first whatever row we're on, now that it's ordered, and q, which is going to give us the last digit in each row, which as we know is the indice. And then all we got to do is return my vector. Okay guys, so here we got our code and we're just going to test it out to see if it runs. And we accepted the test case. Now we'll submit. And as we see, it passed the test. Alrighty guys, and as far as space and time complexity, the time complexity is going to be O(n) log n, which basically arises because the sort operation divides the list of the size n into 2 approximately equal sized parts on each level of recursion, and then has to examine almost every element on the list on each level of recursion. And as far as space complexity, it's going to be O(n), n representing the k, which is the level, how many indices we have to store in our vector. Anyways guys, I hope that helped a lot. If you have any questions or concerns about this problem, if you want me to elaborate more, please just leave it down in the comments below. Also leave down in the comments which problem you want me to see do next. Thank you guys for watching. Don't forget to like and subscribe.